Trader. It's great to see you all out on this freezing night, so thank you for making the effort to come out. I'm Claire, I'm the Tech Resource Partner here at AutoTrader, so I work very closely with the technology teams here. I'm not going to give you a big spiel or anything, but I am here. If anyone would like to learn more about what life is like at AutoTrader, myself and my colleague Lana are here for the evening, so feel free to come and say hi. But we've got a little bit of boring stuff to go through. Housekeeping, we're not expecting a fire alarm tonight, so if the fire alarm does ring, fire exit is down the stairwell opposite the lift where you came in. I'm firewood and trained, so I will be wearing a high vis if we do need to make our way to the meeting point, which is between the tiffin room, Indian restaurant and the inside hotel. And also, if anyone needs any first aid this evening, hopefully you're all going to be fine. But myself and Lana are both first aid trained, so just come and pop over and see us if you need anything at all. And enjoy the evening. Okay. Thank you.
So yeah, hi everyone, I'm Matt Houghton. I'm an AWS community builder and AWS Ambassador. Actually do work for a living as well. I work for a company just down the road called CDL. We use data and AI to power digital insurance journeys. And this talk is the story of our database migration from data center to AWS. The guys have set up a Slido tonight, so if you scan that QR code, you can kind of join in some way, links, questions and stuff like that. So yeah, happy to take questions and stuff like that. So yeah, I joined CDL, on screen now, in 2014. At the time, my job title was Oracle DBA, and we had 2 data centers. Which we operated out of Stockport, and they cost about £4 million each to build. So that's just the buildings, and you have to put stuff in a data center like racks and servers and storage and networking stuff. So the base cost is about £4 million to build.
So was that just one of them?
That's one, yeah. So we have 2. So that picture there. So this is our campus. So that building's ours, that building's ours, that building's ours, all this is ours. That bit is the data centre, and then there's one a couple of miles down the road in the centre of Stockport. Okay. Yeah. So kind of architecturally, our customers are typically insurance brokers, so the easiest way to describe what CDL does, because even though we're sort of local, not a lot of people know about us. But when you go on, say, Compare the Market or Money Supermarket, something like that, and looking to buy car insurance, house insurance, you put in all your details, and about half the prices that you get back on screen are powered by CDL software. So our customers are those brands that you see on screen, so like Sainsbury's Bank, Tesco Bank, Swinton, people like that, they're our customers. And primarily, we sell them insurance policy administration systems, and of course, like most of us work in IT, customers demand high availability for those software solutions. So in addition to those 2 data centers, we built out what we thought anyway, was a robust database architecture running on Oracle, and this is what we have on the screen. So we had Oracle Real Application Clusters. So what this means is within a single data center, if the database failed, it would move on to one of 2 additional nodes, so there's 3 nodes in a cluster. If all the nodes in that data center failed, well, that was okay too, because we ran something called Oracle Data Guard, and what that meant is we could fail over the database to the other data center, which had the exact same 3-node cluster setup. The database software itself ran on Oracle Enterprise Linux with something called Ksplice, which allowed us to patch the operating system with minimal downtime. We ran Oracle Virtual Machine on top of Oracle hardware with CPU pinning to meet license requirements. For storage, we used NetApp, and this gave us mirroring of backups over dedicated links that we had put in between the 2 data centers. And we had monitoring provided by Oracle Enterprise Manager, and we chucked a bit of open source in there just for fun, so we call Rundeck, to help us schedule and manage all of our backup scripts. So, as you can see, we're all in our Oracle here. So we had a team of Oracle DBAs. Wasn't just the database, we also ran our middleware, our application tier on Oracle WebLogic. So there was a lot to look after, but it did all work, and we were rightly proud of the high availability we delivered to customers. So it's all good, everything's running as planned, got happy customers, very little downtime, all good. So then what happened is our licensing deal came up for renewal and the price changed quickly. And it became apparent to us that we needed to be able to move to another database engine to basically continue and have a cost optimized solution. So at this kind of point, it's late 2015. We'd also started to look into the cloud with AWS, and we kind of just dipped our toe. We were developing a brand new product on AWS, but vast majority of our critical running systems were all still running in the data centers that we built ourselves and all running on Oracle. So because of this, we didn't go all in on cloud. We still saw a need for kind of these on-premise deployments. So at this point, kind of financial services, still unsure about the cloud. Compliance team is not up to speed with benefits of like security solutions within the cloud and the benefits of the cloud. So we kind of looked at like the hybrid option. So we had some of our DBAs start to look at building out a Postgres architecture, but that had to work both in the cloud and on-premise. So this is the architecture design that we came up with. We spent about 6 months trying to develop this kind of on-premise architecture you see here. So you've got Postgres running on the VMware servers, sticking with NetApp for storage, introduced Patroni instead of DataGuard for our failover. So this needed a distributed configuration store, so this is where etcd comes in. At the time, NetApp didn't have a driver for Postgres databases. We did a lot of snapshots, so we had to write scripts and workarounds for this. We did get this stack built. Then one day we did an upgrade on the Patroni component of this. At this point we're still in development, but it failed and we got really, really stuck. And it did take us a while to kind of get it all back up and working. Again, at this point, kind of CDL had announced that we were going to be cloud first, but we weren't cloud only. But in this case, the data engineering people took a decision not to build out a database service like this on premise. It was going to be too much work, and what we found was that we hadn't actually yet got to work on the business problem, which was the migration of our application from Oracle to Postgres. What we were actually working on is plumbing that we thought was needed so that we could work on the actual business problem. So this is where we move up the stack. So, kind of failing fast, I suppose, 6 months, if you call that fast. Kind of easy to write off all that on-premise work as a total failure. We didn't see it that way. The team at this point were still Oracle DBAs in their actual job titles and contracts. So learning Postgres from that ground up level taught us a lot and really helped us out later on as well. So moving to Amazon RDS removed a lot of the fear that the team had with all of that kind of plumbing work and the potential failures that we might need to deal with. You know, all those customized components, they're writing workarounds for lack of vendor support for Postgres and things like that. Those are going to be things that are going to keep an on-call engineer up at night. We were still learning, but it shifted away from learning about all the infrastructure that we might need to build. And what we started to look at were things like the Postgres internal, so like things like PG stack statements, stuff in AWS like CloudWatch, tooling like PG Badger, and most importantly, learning the differences in like SQL dialects between Postgres and Oracle. So I'm going to cover kind of migration steps, speaking to some people out here about like using GCP and stuff. So some of this, although it's like an AWS focused talk, there's a lot of this talk that's like Postgres specific, so I would hope that it would apply regardless of your preference to cloud provider. But these are kind of steps that we took in AWS to migrate an Oracle database to Postgres. So the first thing is you need schema conversion. So AWS offer SCT or schema conversion tool. Azure, GCP have similar. Basically, this is going to give you a report on what you're going to need to change. I kind of see this as like a one-time thing. At the back end of this tool, you're going to get a set of scripts that's going to convert kind of schema in Oracle to Postgres that you can actually deploy on a Postgres database. So then you need to get your data over there. So to do this, you really should be using a change data capture tool. So CDC, this will transfer your tables, your primary keys, and most importantly, your data. Then you can look at database objects, so things like views, functions, indexes. Database has code in it, so in Oracle, PL/SQL will need to be converted, in our case, to PG, PL/SQL in Postgres. If you've been using database for a while, then you're probably going to have quite a bit of work involved in removing kind of Oracle-specific functions. If you're lucky, that might just be limited to the database. We weren't. Some of that kind of Oracle-specific functions are corrected to the application code as well. We also found like an Oracle feature in the business intelligence add-on to our solution that basically had no equivalent in Postgres. So a little bit more on that later. That's a story in itself. So how does change data capture work? Well, basically transactions are read from your source online transaction processing database, and in our case we used a piece of software called Qlik replicate. So Amazon have the equivalent for them is like database migration service. Basically, so they read the logs from the Oracle database. The Qlik replicate software converts that to Postgres dialect, and then transactions are applied to, in our case, Amazon RDS instance running in the cloud. We used Qlik as we already had experience with it, so it made sense for us to stick with that as a CDC tool rather than have to learn like the Amazon DMS service. One less thing to manage. So with Qlik-based solution, you can use source database, you need the Qlik replicate software. There's a thing called Enterprise Manager, which kind of manages fleets of Qlik servers, and you also need a target database. And all these components need to be able to communicate with each other, so you've got to apply things like appropriate AWS security groups. So you have defined replication tasks to process the data between the source and the target. We used APIs that are available through the management Enterprise Manager software to automate the registration of the replication servers and also the creation of those migration task definitions. As a side note, what we've also found post-migration is another good use case for CDC is actually to help you move towards event-driven architecture. So not only do tools like DMS and Qlik support like database migrations, they support multiple targets even when you're kind of using like a large relational database as your source. So for example, you could have like a streaming platform like Kafka where you can have stream basically events out your transaction logs in your database, and you can do things like near instantaneous reporting, and you can also move to like modern event-driven architectures that are responding to those events on the stream. So with this, you can, if you've got like a monolithic application, you can start to build out like new functionality in like loosely coupled software components such as like the serverless Lambda functions that we've got here, consuming and processing events from the stream. There's an AWS hero called Ben Ellaby who does a really good talk. You'll find it online, called Minimal Viable Migrations, where he talks about this pattern a lot. He's used in different companies, so I definitely give that a recommend. But like building systems around like event-driven architecture like this, or moving to that kind of event-driven architecture, basically simplifies, you know, things like horizontal scalability, and also makes your systems much more resilient to failure. So by doing a database migration, you learn new skills and new tools that can get you to this as well. So I talked about Enterprise Manager. We're using it to do like deployments. We also used it to track data migration. So the title for this talk was like 600 database migrations. So there was a lot of them going on. So we made calls out to the various REST APIs, and we gathered all of this information from like the replication servers and the tasks, and we fed them at the time. It was into an Elastic Stack. We've since moved to OpenSearch. This is one of the Kibana dashboards that we had at the time. So basically, we were able to visualize the kind of key replication metrics. You can see kind of maximum latency by both like task, current, and over a period of time. You can kind of also see in like the gauge the overall average latency across the entire estate. So we might be running like say 4 large production migrations over a week, and we had like at the start we had like VPN, and then we moved to Direct Connect when we needed more capacity. But you know, you can't just instantly scale up those types of, you know, connections, so you need to manage that. So managing the capacity of network links for a short period of time until you get it migrated to the cloud is really important. And the usual stuff like seeing CPU and memory utilization shown by like both server and task, and then at the bottom, you know, the wall of green showing you the state of each task, whether it's good or bad. So we've got those kind of steps for migration defined and tested. As I said, we did this a lot, so 600 times in our cases. So you can't really do all that manually, or good luck to you if you want to. I wouldn't recommend it. You need to automate. So create the change data capture tasks in kind of CDC tool of choice, and then export those definitions. So our tool offered an export as JSON, and we used that JSON template and made each migration config driven, so finding and kind of replacing client specific items like the host name or the schema name. The automated migration process then basically became like an input file of variables, and we had a process that built out all the migration scripts in an automated way with all the correct customer kind of values in there. At the start of the migration, we locked the Oracle database accounts. So then rollback, if we needed to, was just a case of like unlocking that Oracle database account and switching back the application endpoint. And by deploying all of this as infrastructure as code, doing it in an automated way, you get benefits. So one, reduce your risk. I'm not my best doing manual deployments late at night. I'm going to make a mistake at some point, so you want to remove me out of that situation. Consistency is really important to clients, so if they tested it, they want to make sure that what's going into production is what they actually tested. So by automating it, you know, you're going to get the same thing every time. You're not going to get my flavour of what I think I deployed into test. And crucially for us, you also got speed of deployment, so you can roll out changes quickly through multiple environments and also for multiple customers. And we did that without having to scale up the team. So we've got that initial migration of a database, kind of do that in a development environment, of course, and then what you'll find is you kind of get your developers want to start up the application. So this is what happened to us when we tried that. Well, it failed, was the first thing that happened. So there were lots of like connection, initiation, SQL statements, trying to run, selecting from the dual table. So this is an Oracle only thing. So we basically created like a dual table in Postgres just to like get up and running, and then kind of refactor the application later. My second attempt, the application started, but it was like way too slow. So we had like developers going, this screen used to take 3 seconds, now it's taking 2 minutes or even timing out. So what we saw was a large number of joins in the SQL, and it was also bringing back unnecessary columns. Oracle and WebLogic was kind of handling that mess for us. So what we did, we narrowed it down to about 10 views that were causing the most contention, and then we started to continue with the tuning. And we developed a kind of set of steps to go through. So this is totally Postgres specific now, it's nothing really to do with AWS, so this applies kind of wherever you're running Postgres. So first of all is the join collapse limit. So this is a parameter in Postgres which influences how the query planner can rewrite like the join constructs in the SQL. So when you've got a smaller value on this parameter, it reduces the planning time, but although it is faster because it's doing less planning, if it doesn't have enough time to plan, it might give you an inferior query plan, so your overall SQL is going to be poorly performing. Query planners don't always choose the optimal join order, so as expert users you can opt to set this variable. On a similar note, there's a from collapse limit, so this is where the planner kind of merges subqueries into upper queries. So again, if your from list in your SQL is set to have no more than the number of items specified in this parameter, and smaller values reduce your planning time, but if you don't have enough time to plan, you might get an inferior query plan. Workmem, this sets the base amount of memory that's used by a query operation, so think of like a sort, before it has to write to temporary disk, basically. The default value is 4 megabytes. For like a complex query, you might have several sort or hash operations. Those might be running in parallel. So each operation is generally allowed to use the amount of memory specified in this parameter before it then starts to write to temporary files. So you've got sort operations used for things like order by or distinct, merge joins, all that sort of stuff. So I think we basically just doubled that because we had some quite complex SQL. PG stat statements. So this is a module in Postgres that provides you with the means for tracking, planning and execution statistics of all your SQL statements executed by your Postgres server. So you've got to add this module in by putting it into something called shared preload libraries in postgres.conf file. So that's fine if you're running Postgres on a server. In cloud world, you probably don't have access to postgres.conf. So in a cloud provider in AWS anyway, there's a parameter group that you need to change to add this in. And basically the statistics that are generated by this module are then available in a view with the same name, and the view contains a row for each distinct combination of database ID, query ID, user ID. To kind of complement this, you've got PG pre-warm, which is a way of loading data effectively to cache, so the operating system buffer cache or the Postgres buffer cache. You can kind of call this manually using the PG pre-warm function, but what we did, we included PG pre-warm in shared preload libraries to load it all when the database started up. Turn on logging for your database for any statement. We set the limit as taking more than 1 second, and at the time we sent those logs to Elasticsearch, now OpenSearch for us. This was a crucial thing for us because it targeted which SQL to optimize next and go through these steps. So at this point we ended up changing about 60 different database views, adding to them to like a dev environment one at a time, testing before then making sure they got put into the actual code base properly. We still actually have the dashboard for this running on the databases, so we call it our proactive dashboard. So if all of a sudden we get rubbish SQL, we will see that in a non-prod environment before it affects customers.
Do you have an open source ISE for that?
I'm trying to think what we do with that.
'Cause we've been doing something similar recently and we've been hitting some issues.
Okay. Don't think we've open sourced it, but we can probably write a blog post. Don't see why we would restrict that. Yeah. But yeah, we're basically logging in AWS. We're logging out there. We're taking the Postgres logs and just dumping them into OpenSearch. Yeah. So we've got like scripts that do it. So yeah, probably get one of the team to look at doing a blog on that if it's of interest. Yeah. Get some ambassador points for that as well. So there's like some tools as well. So this might come in kind of handy as well. So we use all of these things. So we've not found like one magic tool. So there you go. If you know of a magic tool, please let me know, and we'll switch to that. So yeah, have your Postgres logs shipped to AWS CloudWatch logs. There's a good one and easy enough to do. If you're in Amazon world, RDS Performance Insights. So this is the database performance tuning and monitoring feature. PG Badger, it's got nothing to do with Amazon, so this is a Postgres log analysis report tool. So yeah, lots of tools. The tools change over time, but those are the kind of ones we've generally stuck with. What was more interesting to me anyway is what happened like organisationally. So the DBAs were now kind of using RDS in AWS. Because of that, they're not installing database software anymore. They're all of a sudden got more time to work directly with the developers on making the software better. Found by accident we were doing DevOps. So DBAs sat next to developers, working together, not raising tickets to talk to each other. It's a good way of working, it seems. So yeah, touch there on DBAs not installing database software. RDS is also patching and doing the backups. So what do the DBAs do now? Well, we've still got them. We didn't reduce the size of the DBA team. If anything, it's got bigger. What we found is automation on top of the automation. So they build and maintain Terraform now for our infrastructure as code. They build and maintain pipelines. They use open source tools like Atlantis with Terraform, so they can roll out changes to new environments quickly through config. They move the database technology on way faster than they ever did before. So to give you some context, on-prem, our Oracle 11G to 12C upgrade, that took us a year to complete. Now we have RDS and we have automation. We can move between major versions of Postgres in 4 weeks. This is something we're actually throttling ourselves. We can actually just essentially press a button or run a pipeline and do all the databases in one night. We can roll out to new clients faster. We can roll out critical bug fixes faster. We can basically now go as fast as the business want. The tech isn't the bottleneck anymore. It's actually risk appetite from either customer or CDL. That's a nice place to be as engineers. Yeah, so the DBAs now think about like CDL growing. So we started off with like 600 databases in 2021 when we migrated it. So what happens when we get to 1,000 databases, 2,000? Well, it's not really an issue because that's just config. It's just a deployment. The number doesn't really matter anymore. I'm making this sound very easy. It's certainly not. The automation doesn't just happen. But if you're not installing database software, you've got more time to do it. So, yeah, that's a critical thing from an organisational development perspective. The other thing we saw was this automation also improved the developer experience. Go on.
Yeah, I've actually been thinking about asking this question at some point. You mentioned that before you used to be everything on-prem,
yeah.
and then it changed once you realized that obviously Oracle's price increased significantly, and so you wanted to go like provide like something that was better value for money, and then you ended up choosing like kind of the cloud. But then you said that for compliance and some of the other business departments in the company, you still retain a big portion of it on-prem. So my question is, what were the main concerns and what were the main reasons why they decided that some of it needed to stay on-prem?
Yeah, so in the end, it didn't stay on-prem, but we had a period of time where we needed that to go out and speak to the customers and basically have like a hearts and mind discussion to educate them about the cloud and its security posture and the compliance, and do all like the due diligence with their security teams and their compliance teams before we did the migration. So that was like the bit that actually took the time. So we kind of said, look, we're going to do this. These are the benefits. You'll have questions. We're here to answer them. And we kind of went out with kind of not a sales pack, but because we'd already sold it to them, but a set of kind of answers to satisfy all like the security and compliance requirements. And once they, I think, understood that things like security and compliance can often be easier to achieve in the cloud, because like you're not worrying about like the CCTV cameras you've got in your data center when you're in the cloud. That's just not a thing you worry about anymore. You're focusing on more important things that matter to them rather than things that don't really matter. That it's just like table stakes kind of thing.
Oh, but there is also CCTV going in the cloud.
Yeah, that's not my problem anymore. I just call it API. So yeah, it absolutely matters. But it's easier to achieve because AWS and the other cloud providers have already gone through that kind of verification process and have all those certificates that, like in AWS, you can like download it from like artifacts to say, like, pick a compliance requirement, download the certificate there, it's done. Whereas if I start from scratch and try to achieve that compliance requirement, that's like me setting up a project, bringing in compliance and security people, writing policies, writing technical controls to implement those policies. That's like a lot of work and absolutely vital that it happens, but my business is helping customers sell more insurance policies, not making sure the CCTV or the locks on the door are good. So it's allowing me to focus my efforts on achieving the most value for the customers. So I think once they see that, and some take longer to see that than others, they do. I think.
Has any of your customers still wanted to keep some of their business activities on-prem?
No,
or
so
they
we
are
don't,
not?
yeah, so we're completely migrated to AWS.
So it's fully like 100% on the cloud.
Yeah. So we've got, so I mentioned the 2 data centers. One of those is shut down. I think the building's up for sale. The data center we have on campus is still there. I think it's got like a couple of like servers, but they're not really even in the data center. They're in like a cupboard now. And that's just for stuff that we run internally that is like, it's just not something that runs in the cloud. It's like got a limited lifetime, so like 2 years or something like that, so you just don't migrate, you just leave it there. It just runs and that's it, but yeah.
What kind of stuff is that?
Sorry?
What stuff is that?
It's got sort of VMS, a couple of VMS things, yeah. So you don't really run those in the cloud, but all of their like the customer-facing stuff, that's all in AWS.
When you say VMS, do you mean virtual machine or is somebody else?
Yeah, so no, it's like I think HP own the rights to it, so it's like a mainframe type thing. Yeah, it's got a couple of VMS things still going.
So what is that for? What does that do?
It's for one of the previous systems, one of the previous incarnations of the system. Yeah. Yeah, so kind of talked about a bit on developer experience, some of the benefits here. So probably seen like if you developers, you probably ask for like clones databases. So we've basically got a self-service portal now where people can request clones of databases. So you might want production volumes to test bugs or whatever. So we basically got automated processes now that do point-in-time recovery of production databases. We'll downsize the instant class, make it like single AZ to save on costs. There'll be like an automated masking process that's run to protect sensitive data, and then developers are issued automatically with like a set of credentials, and then they get a few days to test with it, and the database goes. So for like, we used to have something similar on premise, like that process used to take like 18 hours to do on premise. So basically now we're pre-doing these snapshots all the time. So like an 18-hour process on-prem basically takes like 18 minutes in the cloud. So like developer productivity is just massive. Things like an 8 terabyte database, just to give you a kind of sense of scale, that's ready for a developer to use like within 30 minutes. So we're not really waiting that long. Things like pre-approved queries, so developers might want to check config, production database, but obviously not access like proper sensitive production data. So you can make like pre-approved queries available in self-service portal. In the event of an incident, often like DBAs used to get asked to run like health checks on the databases. So rather than wait for a DBA, just make that available through the developer portal. Developers can crack on and do those triage checks themselves, not wait. They don't wait around anymore for DBAs to like export and import data. All of that can be done. Effectively, the database has become a product within CDL. So we're using RDS, but we've added like value on top that's specific to our needs, and that's been like the DBAs are now going out speaking to like developers as their customers, and basically writing code and creating automated processes. They're building a product. They also actually changed their job title and their contracts, so they're not called DBAs anymore, they're called data engineers. Because of the extra time they've got now, they've also got new skills, so data engineers now not only work on like relational databases, they are using EMR, Python, Spark, Buddy, Athena, QuickSight, just a few of the things that we use in CDL. Whereas when I joined, I was an Oracle DBA and that's all I did, so it's much more interesting and fulfilling as well. Rapidly running out of time, I've gone over already. So a thing called RDS Ready. If you are going on AWS, basically it's like a specific lens that's part of the well-architected framework that teaches you how to run RDS to a set of industry or AWS best practices. If you're building like a product that uses RDS, it's well worth doing. We've got 2 of these RDS Ready competencies. Sits on my shelf at home. That was 2021. We're on the big screen at reInvent, and we won that trophy. Just one of the launch partners for it, so that was pretty cool. So yeah, look into RDS Ready if you're an AWS partner, because it's a good set of standards. So I won't go through them.
So what does RDS stand for?
Relational database service. So basically, Postgres or MySQL or Microsoft SQL Server provided to you as a service, so you get a database connection string, and away you go. You don't have to get a server, install the software, patch it, back it up. It's all taken care of. You call an API, you get a database, you get a connection string, and away you go. Couple of things. So open source. I mentioned there was a feature that just wasn't available in Postgres. So that was fast refresh materialized views. So that was a feature in Oracle. Postgres didn't have that. So we actually had to work with a team in AWS called the Database Freedom team. So we wrote fast refresh materialized views for Postgres. Scan that QR code, will speak to me after. There's a blog post about it. This chap here, Tony Mullen, he was the lead engineer on the project that I'm speaking about. So Tony did all the hard work and I get to take credit for it. He must have been really good because AWS poached him to go and work for them. So he's now a senior solutions architect specialising in RDS, where he basically does what he did at CDL but for like customers all over the world. Really good. He wrote a blog post for AWS while he was working at CDL. So yeah, if you ever get a chance to hear Tony Mullen speak, he is based in Manchester, so he's a good guy. I jump at the chance to hear him speak. But the code for this fast refresh stuff, that's all on GitHub. You can have that with our blessing. I won't tell you how to use it because I have massively run over. But I will finish with a final tip. So hopefully you've kind of seen like the cloud providers, in our case AWS, have got some like really awesome building blocks. But for me, one of the key kind of things for the migration to succeed at the scale that we did was we needed help from all of our teams. The engineers doing all the things that I've kind of spoken about, this technical meetup, but also we had like involvement of like legal, compliance, project management, operations teams, and also like customer teams to make the transition of our flagship product to cloud only. So we felt it was important to recognise every migration. So this is our restaurant, our campus. So every time we did a migration, we hung a cloud and we put the customer's logo on it. After the last migration completed, we had a cloud celebration day. So had about 200 CDL people come to our campus for food, drinks, and some fun as well. We gave out like awards for like key individuals, but everybody at CDL, whether you were technical or not, got given an extra day holiday when the cloud migration was completed. So I thought that was a nice touch to recognise the input of everybody on that journey. So yeah, I would think about like, the technical aspects of your migration, but also the people aspects are equally important. So yeah, thank you very much for listening, and sorry I've gone over.
Questions?
Yep.
I'm
I have a couple of questions.
Yeah, go for it.
Yeah, sorry. I think, should I ask everything at once?
Yeah.
Just like 4 questions.
You got like 100 now.
No,
You got
just
like 5 maybe.
Yeah, understand. When you are operating Oracle
Yeah.
on-prem, and you are I just presume that the connection will be via IP addresses.
Yeah. So we were using RAC, Real Application Clusters 1. So that kind of 3 nodes in a cluster, and then mirrored to another 3 nodes. So what you have is basically DNS type address of like a floating IP that kind of moves from node to node. So if like node 1 falls over, you keep the same DNS and the IP kind of floats to the next node. So that's how Oracle manages the failover.
Yeah, because I was thinking probably on AWS is DNS endpoint mainly. So I was just thinking if you have to move from IP to DNS.
Yeah, so so if you're setting up a database on AWS, basically you get given a DNS entry. Yeah. And behind the scenes that'll be, depending on the configuration, it could be a single node, it could be multi-AZ, it can be even like global across region, depending on if you're like using Aurora and stuff like that. The details on that, you're largely giving that problem to AWS. You pick what we do is we go, what does our RTO and RPO need to be, and what's the SLA for the system overall, and we pick the architecture or the service that matches those characteristics. So for a dev database, does it really need to be multi-AZ, global across regions? For a developer who works 9 to 5, no, I would say. If it's for a customer who trades 24/7, then you at least want it to be multi-AZ. So yeah, match that and test.
Multi-AZ in
test
active standby architecture, right?
Yeah, so for us, typically we are multi-AZ where it's active passive. So if we do a failover, there'd be a short outage. But that's
right.
So no, because AWS would fail it over for us. What we do have to do, so part of RDS Ready that I mentioned is that we have to show, in order to get that accreditation, that we do test that. So what you don't want to be is surprised when that event happens, because it probably never will, because the reliability of AWS is so good. But if it does happen, you want to have practiced it beforehand. So we practiced it at least once a year and document it to get that accreditation. In practice, because we're doing those database snapshots every day and restoring them to developer instances, we're constantly, every kind of 6 hours or so, testing backup and recovery.
Okay.
So that's another good way to do it.
Yeah. Your disaster recovery, is it just multi-AZ or multi-region?
Yeah, so depends on the client, so that's config driven. So we offer like tiers, if you like. Most clients are multi-AZ within a single region. Got a couple of clients where they've got the data going to a secondary region as well.
And the last question, sorry.
Yes, okay.
How do you handle heavy reads? Like, do you have like dedicated read replica?
Yeah. Again, it's config driven. So yes, we use read replicas. And the heavy reads tend to be, in our experience, from like analytics workloads, BI, MI workloads. So what we do with them is we use the same migration the same CDC tool that we did for the migration. We run that in production to mirror the transactions in real time to a secondary RDS instance, which is also multi-AZ and can have read replicas. And the analytics workloads are run on that, and then the OLTP workloads are run on your main database. And keep the two workloads separate, because unless your database has like workload management type software or features built in, the two workload characteristics, as you kind of said, are very different. OLTP does not look like analytics, so you would size and tune differently.
Thank you.
Okay, just like maybe go down the line.
As I remember, you can run Oracle DB on Amazon LDS.
You can, yes.
Yeah, so it sounds like the main cost reduction was done by saying goodbye to Oracle. Actually.
Correct.
Yes. Where is the win from moving to AWS? Like, I got it. Goodbye Oracle.
Yeah.
Makes sense.
Yeah, so at the time, anyway, for us, the team was skilled in Oracle, so it was having enough skills in place to deliver the high availability that we're already delivering to clients with Oracle in a Postgres environment. But to do that on-prem was very difficult. You can't just buy like an extra license pack and turn on that feature in Postgres, because it doesn't exist because it's open source.
But you can write.
You can write. You can absolutely write. And there's a lot of people that run highly available Postgres databases on bare metal servers in data centers. For us, it's a question of where do we spend our engineering effort. So I go back to that point I made. My job as an engineer, as an architect, is ultimately to help my customer sell more insurance policies. So the more insurance policies they run on our system, the more successful we both are. So if I'm do I spend my time helping them with that problem, or do I spend my time being a really good Postgres, highly available on-prem DEM? I know which my customer would pick.
Yeah. Asking because we use it, not Postgres, MySQL in
Yeah.
RDS, and one company with that specific task, we found that managing RDS by AWS was not so well for us, because you can't actually tune it as you can do a bare metal database, because AWS doesn't allow it.
Yeah, so you're losing, so it's definitely a trade-off. You're losing some control over it, and we do see like, when I speak at different like AWS data meetups and stuff, particularly in the Oracle world, you do see a lot of people with very specific use cases of why they need to get into the OS and tune that. So you like look at Oracle, you can now do like RDS custom, I think AWS call it, where you can run it on AWS, but you still have the like access to the underlying server.
Oh.
So it's a bit of like a best of both worlds. That tends to be for like what I've seen anyway, and I've got no production experience in this, but all the customers I've spoken to is if you're like running like Oracle applications on Oracle databases, But yeah, so they offer like that. Not sure if they do like the custom variants for other flavors of databases. Sure. Yeah, it's a good point. Yeah.
I don't know. I don't think you should extend on the Redis database, but with MySQL process already. I don't know.
Yeah.
It's quickly.
Redis is another topic, because obviously they
I mean
support that now, haven't
I
they?
know that there's a possibility to upload your custom shared libraries for
Yes. Yeah, yeah. I see what you mean. Yeah, yeah.
Sorry guys, when you say lose control with the AWS rather than on-prem, which are the main things when you talk about that?
So you don't have access to the operating system, I would say, is the main thing. So things like
Do you know at least which operating system you run is on?
No.
No, you don't even know.
Yeah, it's
definitely not Windows.
yeah, it'll be. I would imagine it's Amazon Linux. But yeah.
Last question.
There's like 3 questions. I'm gonna pick.
It's going to be a fairly quick one.
Okay.
Are you afraid of vendor lock-in?
It's one you get quite a lot. I think what I found is probably, and this isn't like specific to CDLs, like all organisations I've worked in, I think you're probably more locked into like your internal processes and things like that, and your organisational structures than you are anybody else. I think certainly for us, I've been sort of like talking about this today with our boss, because we're doing like code companions at the moment, and AI, and then we're looking at the Amazon one and the GitLab one, and I've gone like we should just go with the one that's the cheapest at the moment and learn to be how to be more agile, so that when the other one lowers their price, we can move to that very quickly. Because they're all very similar, and they all have little pros and cons and all little niggles. So really, it was like it just became like a financial thing, and it's have you got like similar like warping maps where you go from like Genesis, improve like to commodity, all the commodity stuff. You like you don't worry about that. It would just be it's like nobody really cares who they get their electric from. I should say in insurance, nobody really cares who they get their insurance from. They just go with the cheapest price on the price comparison site. So that insurance, I suppose, in ways, and commodity. But yeah, I think some of that sort of stuff is largely like commoditized with the cloud. So I would say one of the things is to treat them as a partner rather than a supplier, and engage with them and give them feedback and see how they respond to that feedback. And if they do respond well with like roadmap items, then why would you move?
Good stuff.